So let's get moving on the academic application of writing systems and why they matter for college students or students in general trying to figure out school. So I'm going to have two videos here. The first one is going to talk generally about academic application of writing systems and common stuff like that, and also a little bit to connect with chemistry. The next video is going to be math oriented and writing systems and how math is a language. Either way, if it helps kind of provide some context for this, yes, I'm a writing instructor. Yes, I have a PhD in writing, rhetorics, and literacies. What we're talking about here is an application of those things to some fields that I'm interested in and that I also have some experience with. So when I started out college, I started out as an aerospace engineer. So that was fun. I came into college having gotten through calculus. So math hasn't. So I'm one of those weird writing guys where math actually isn't as big a challenge. And I think some of the things I'm going to talk to you in these videos about will explain why a little. So with that, I also since 2016 I've been doing a learning community, which are mashed up courses. So a 3-credit hour writing course, English 101 or 102, with a 3-credit hour intro to chem course, and I've been doing that for years now. I've also done 3 semesters where we've mashed up, done a similar type of thing, learning community, with English 101 or 102 with Matt 187 or Matt 151, and those sorts of things. So that would be your intro to college algebra, I think, and kind of the equivalent of a pre-calc class. So the 187 has college algebra and trig blended together. So my 3-credit hour course with that 5-credit hour 187, or my 3-credit hour course with a 4-credit 151. So as I talk about these things, I've done these in the classroom a bunch of times, but this is supposed to say, all this to say that these are some of the important ways that writing gets applied into other classrooms. Sometimes this is called writing in the disciplines or writing across the curriculum. Suffice to say, writing principles and principles of communication show up in every part of our lives, and some of the reason that people struggle with certain subjects is because they don't realize that writing is the issue, or the language is the issue, that it's a new language, it's not English, and so keep that in mind as we dig into this. With that, I've already covered what these common types of writing systems are in the other video on writing systems, so let's just push forward here. There are, and I'm sorry for the format, it went from Keynote to PowerPoint, sorry. But there are common borrowed writing systems. There are many types of writing systems throughout the world and that exist. Within the context of English, specifically academic English, and maybe in this particular application, more specifically English in the sciences, there are power languages that are drawn from. So a lot of the writing systems that are built into English, which is a blend of multiple languages, come from these. So we see a lot of specialized language in the social sciences and humanities and in natural sciences being derivatives of Latin or Greek root words. So those two, that's one of those reasons why in high school, if you had an AP class, your instructor may have had you do some of those Latin root words, or if you did SAT prep. The reason those things are important for college prep is because so much of academic language is built on the root words that come from Latin and Greek. So that's important. And we also borrow a lot of terminology. We borrow terminology in mathematics from the Arabic languages, terms that show up in mathematics like algebra or algorithm, which is the root of a Latinized form of algorithm. We get language from Arabic, or we get language for mathematics from some Arabic scholars in mathematics from a long time ago. So that's one of those reasons. When we look at chemistry, specifically early era chemistry, like 1800s chemistry, we see a lot of Germanic roots, a lot of German language, and so there are some who say you can't get a PhD in chemistry without learning German, or at one point in the arc of chemistry that was the belief. All of these are systems that academic English borrows from to build words, or uses that morphology principle. So we have where there's a prefix, a root word, a suffix, or any number of modifiers along the way that build that word. And so there's a logic behind the language, there's a logic to how things build meaning. So if you're dealing with new writing systems and new language, remember it's not not just English. It's a different level of English, a different type of English, a different socio-cultural context of English when we're talking about these things. So we want to be aware of that. With that, I do have resources for root words. This should be in the Canvas course. If not, I can. Yeah, these are links. You can Google all kinds of things on Latin and Greek root words. They're not that hard to find. So those are there. When we talk about the application of writing systems, we see one specific thing in the sciences of chemistry nomenclature. And so this is the specialized naming logic for chemistry. Nomen comes from the same root that we get nombre or nom in French and Spanish from. And so it's the root word for name. So this is the chemistry naming system. It's how they name chemicals in chemistry. And there's a logic to it. Some people who don't like language, or I know some instructors say, oh, I hate nomenclature, even though I teach chemistry, because it just feels like it's a bunch of memorized facts and I just have to memorize it. There are some rules you can apply, some guidelines or principles. Rules may be a little strong, but the words are built in certain ways. And so we want to be aware of that system or some of the possibilities. There is a whole crash course video on chemistry nomenclature, though it might be a little more advanced. I'm not trying to push into it too far, just to say that here are some of the things we might look for or see. So when we are relating between different systems, when we can see scientists often pit one language system against another to create distinct logics or structures. And so one form of that is in the metric system. When we look at it, there's a history to these documents, to these systems of writing. And so actually, as a writing scholar, I geek out about it, but it's interesting to note if you're trying to figure out some of this. First, there are, as we look at the metric prefixes, the ones above the first unit or the 1 unit, they count up in using Greek prefixes, and the ones below the first 3 places into the decimals, those are based on Latin, and then it shifts back to Greek after that, I believe. But the reason there is that is the history behind it. The history behind this writing system, this communication system, is that those first 3, those sets, those first 3 above and below, those were developed as a unit. I think it's 150, 200 years ago in the 1700s. I think is that when the history says. I think I've got a timeline coming up. But that core section in the middle there it was all created at the same time. And then as science got more and more advanced and tools became more and more precise, they had to take out to those to the septillion or septillionth. And so they just ended up defaulting to Greek. But there's a logic to the system. Those people who originally built the metric system, those scientists who ratified it, they did it with, they tried to use the root languages people were familiar with in the academic language of the time to create a distinction. So that can be helpful. If nothing else, it's proof that there is logic behind why things are called the things they are in whatever field of study you're in. So keep that in mind. Okay, I'll see if it takes me to the right link. So sorry if it gets funky for a minute here. Let's give it a minute. Nope, that's the wrong source. Never mind. Just kidding. Now I gotta move my face over. So sorry about that. I thought that was a different link. We'll see if it shows up. That's probably the one I want. Of course. So this is what happens when you're used to doing this in class. Nope, this isn't it either, but it does have some interesting early periodic table sources. So I'll go ahead and shift to that and skip the metric system stuff. There's a link somewhere in here with history. But the periodic table is also another one of those things that has writing systems embedded in it, and its history shows people trying to classify chemicals and organize them in structured ways. And so early forms of this would be Dalton's periodic table of elements, and based on his knowledge of the time, he created this system, and even some of the key bonds and that sort of thing, to be a way to represent all the information that chemists had at the time, like as a quick reference guide. This is before things like, if you're in chemistry, this is the precursor to things like Lewis structures, which is how we now build the system we now use to encode information about molecular compounds. This is also precursor to the periodic table, which many people have seen, even if they don't like it or haven't taken a chemistry class. This is somewhat familiar, so we can look at a periodic table with all its color coding systems and everything, and this is now where we're at with some of those chemistry things. Sorry for the jumping around here, but so when we look at systems in writing, we might look at what writing systems are present in the periodic table. So let's pull that back up. Where'd my, nope, there. So if we pull up a periodic table of elements, we might say, okay, what are the writing systems present? We talked about some already. And so this is an option. So if we look at this, a chemist will talk you through things like periods and families and all of that, or periodic table trends. And the crazy thing about the periodic table is that it is an example of what happens with revision over time. So this is a text that has been developed and processed and maximized over a period of 150 years, or to 200 years, corporately, by scientists across the world. And so the reason sometimes people struggle in chemistry is because there is so much information embedded in this one document that if you don't know how everything fits together, it's hard to do some of the necessary things. There's so much information that's just visible, but also there are color coding schemes. We could look at the visual design of the table, but for now, if we're just looking at writing systems, we could say, okay, what are some obvious writing systems that show up on the periodic table? Well, there's alphabetic systems. So we see, things like Li for lithium, H for hydrogen, He for helium, Ne for neon. So there's a direct correlation, letters to the full word alphabetic system. Some would say there's phonographic writing systems present because that lithium, Li for lithium, is directly connected to how that word sounds. And so it's carved out sounds. There are numbers there's simple numbers, and then there are Roman numerals. So we see multiple numerical writing systems. Even as we look, though, what do we do in situations with like lead for PB? If we are looking at, in chemistry, if we're looking at PB equals lead, what kind of writing system is that? When we look at PB for lead, it doesn't have a phonetic correlation like He for helium or Ne for neon, and there are a couple of these reasons. There are a couple of reasons why. But if you don't know the history of lead and the PB symbol, you don't have a way to think about it. You don't have a way into remembering its connection. So in this case, it becomes something you just have to memorize, because PB actually links back to the root word for plumbum. Plumbum is the same root word we have for plumbers, and we used to use lead pipes and that sort of thing. So there's this direct connection to a root word that it has been that is now no longer the common thing. So PB is now lead, and so as we look at the periodic table, that writing system for some of those things that you just have to memorize, even though it looks alphabetic, even though other things around it are phonographic, this becomes logographic, because it is essentially, there's an idea of a chemical behind it, but the images of P and B, the images that look like the letter P or look like the letter B, combine as a symbol to communicate the idea of lead. And so that becomes logographic. And so it's an interesting thing to look at some of these other disciplines and see how does writing play into how knowledge gets encoded in the information. So that's where writing systems, as I said in the other video, they're not just language, they are also technology. We develop new language and we develop new ways of putting symbols together so that it's easier for our brains to take in information. There's a fun story behind the periodic table and how it got organized, but it was, go look up the history on Mendeleev and the periodic table. It's a fun story about how he came to the first version of the more complex periodic table. But suffice to say, we could just as easily have replaced PB on the periodic table at this point with the symbol of with a peanut butter and jelly sandwich emoji or a poop emoji, as long as it helped us remember that was lead. We could have also put a little pipe there. So then what is this compound in chemistry language? PB, J1, B1, B2, that would be peanut butter and jelly sandwich. Using the writing system for chemical compounds, but not actual elements from the periodic table. There are different forms of writing systems we could look at, different ways for naming acids, what prefixes and suffixes. So I'm not going to go into all that because you can find those sorts of information other places. I will say that as you try and come up with ways to connect to content in other classes, think about the writing systems embedded in them. I will likely talk about in more detail at another time about genres in the chemistry classroom and other ways that writing comes into play, visual design in the periodic table, that kind of stuff. But this was just to think about writing systems. How do we encode information in a system? What's the logic behind the language? And how does it help us function or communicate more effectively in this specific academic context? Hopefully this helps, even if it feels a little scattered. Sometimes that's just how it is.